Good morning, students. So we have come to the conclusive part of our first lesson in chemistry, chemical reactions and equations. On the previous day, we stopped after discussing four kinds of reactions: combination reaction, decomposition reaction, acid-base reaction, neutralization reaction, and precipitation reaction, and then we stopped and left the three reactions: displacement, double displacement, and redox reaction for today. I asked you, if you remember that, look up what is metal reactivity series and try to explain also how to find the relative reactivity of metals and also non-metals. I told you metals, but I discussed also the non-metals because they are also more reactive or less reactive than each other. And what are the comparative reactivity of all the elements? This is the reactivity series. Like if we go to the reactivity series, the basic reactivity series, you will see that hydrogen we also placed in that brief series. These are, you have to learn through and through your next classes also, upper classes. Here we need only a few. Just look what I taught about this reactivity series and the periodic table. Have to look at it, one way of find the reactivity of the metals and non-metals both. Look at that backlog. Although I told you that reactivity, you need it more, the reactivity series of metals. Actually, metals and non-metals, in fact, all the elements can be arranged in a reactivity series in order of their reactivity. So, we give the definition of both metals and non-metals here, though you need more about metals in this class. The arrangement of metals or non-metals in a vertical column in order of their decreasing reactivity from top to bottom is called the reactivity series or activity series of metals or non-metals. In fact, the elements, if you ask me like that, relative reactivity of metals in relation to each other or non-metals helps us understand which element will replace which in a displacement reaction, which we will discuss tomorrow, next class. Look at the series. Here you see why I am telling that actually it is a reactivity series of both metals and non-metals, because you have seen in red letters carbon and hydrogen here, which we place among this reactivity series among the metals to show which one is more reactive than the other so far elements are concerned. Now, there is a general rule about knowing which element is more reactive than other, which metal, which non-metal, that you have to practice in the upper classes. In the next periods, we also will discuss about it. But let's have a basic look at the periodic table. You see, periodic table, if you ask about the metals, periodic tables have columns and rows. Vertical columns, these are called the groups, and horizontal rows, they are called the periods. The reactivity of metals, remember it carefully, reactivity of metals increases as we go down a vertical column, and reactivity of metal decreases as we go from left to right along a period. So, if you look at any metal, which metal will replace which, and you are given names of two metals, you check their position, which one is upper, then it is less reactive, and which one is on the left side, then it is more reactive in that way. Now look at the non-metals also. Non-metals does the opposite. Non-metals reactivity decreases as we go right to left, and reactivity increases as we go from down to upwards. These ones you will practice. If you just go on practicing from now on, it will be easier. The elements in this last column are all almost non-reactive. That's why they are called noble gases. So displacement reaction is such a reaction where a more active metal or non-metal, a more active element displaces a less reactive element from its compound. A less reactive element has a compound and it is mixed up with the more active element, and the more active element replaces the less reactive element. Let's discuss first with the metals. It is more common. Suppose we put some ferrum, you know, it is iron, in copper sulfate solution. Now if you go to the reactivity series, you will see that ferrum is placed upper than copper. Ferrous is more reactive than copper. So what will result is that ferrum will displace this copper from its compound and form the sulfate solution by itself. It has replaced, and this copper becomes solid. This is how a more reactive metal replaces a less reactive metal in its compound. Another example we can give, say zinc. We mix it, say, with hydrochloric acid. That is dilute. What happens then? It's a metal, it's a non-metal, hydrogen. But zinc is more reactive than hydrogen. So zinc replaces hydrogen and forms zinc chloride aqueous solution, and hydrogen, it goes away as gas. If we had mixed with Zn with say H2SO4 in its aqueous solution, that is sulfuric acid, same will have happened. Zinc being more reactive and hydrogen less reactive. The more reactive element, metal or non-metal, will replace the less reactive element, metal or non-metal, from its compound Zn, SO4, zinc sulfate, and H2 is separated and go like this. Look at some more examples through slides. Look. The reactions in which are more active, we already talked about this, how iron replaces copper from its sulfate solution. Let's look at the picture how it is done. You see this, in this picture, the blue copper sulfate solution are taken in two test tube, and in one test tube an iron nail is put with a thread. Very soon it will be seen that the nail, it becomes shining because the ferrum is now replaced copper sulfate in the aqueous solution, and the copper is deposited on the iron nail. So you see how in this experiment we have seen that iron displaces copper from the copper sulfate solution, and copper goes on depositing on the iron nail, changing its color. So you understand that displacement reaction can be of three types. The first type is where a active metal displaces a less active metal from its compound. You see, zinc and copper sulfate aqueous solution. Zinc being more active metal than copper, zinc forms the zinc sulfate displacing copper. Now there is another reaction, look at it. It is an example of displacement reaction in which a more active metal displaces a less active non-metal from its compound. You see, sodium and water. What happens is that sodium is a metal and hydrogen is a non-metal, but sodium being more active than hydrogen, it replaces hydrogen to form sodium hydroxide in its aqueous solution, and hydrogen as a gas goes away. The third example of displacement reaction, third kind of displacement reaction that can happen where a more active non-metal displaces a less active non-metal from its compound. Here you see chlorine gas and potassium bromide in its aqueous solution. Now, you see chlorine and bromine, both are non-metals, but chlorine being more active than bromine, it replaces bromine and forms potassium chloride aqueous solution, and bromine as a gas flies away. If you go through the your reactivity series on basis of what I taught about the periodic table, it will be easier to understand here. Now the double displacement reactions, where when you are mixing or reacting to compounds, what happens that two different atoms of different elements, or in maybe groups of atoms, two different atoms or two different groups of atoms, exchanges each other, replaces each other in their previous compound, the other component of the compound. In such a reaction where two different atoms or two different groups of atoms are only exchanged, we call it double displacement. You see, it usually happens in the ionic compounds. We learn about them at a little higher classes, but as well you can learn it in another angle. Since these usually happen in the ionic compounds, we can also explain this double displacement like this, that when two ionic compounds in a solution react by exchanging the ions and form a new compound. Two ionic compounds in a solution exchanges their ions to form new compounds. We call it double displacement reaction. I will give you some with metal and non-metal and also metal and metal. First look at it. Let us say we take barium chloride in its aqueous solution. I am not going in the ionic part, you will learn it later on. And we put it with sodium sulfate, also aqueous. What happens is that a barium sulfate along with sodium chloride aqueous solution is formed, what happens is that if you look at it, barium and sodium, they exchange themselves in their respective compound. Sodium comes and attaches itself with chlorine, and barium goes and attaches itself with the sulfate part. This is called the double displacement reaction. Usually this kind of reactions produce also a precipitate. I told you that often two or more reactions happen at the same time. We separate them only for the easy learning sake. Because this barium sulfate, it comes down as a precipitate. Why it is precipitate? Precipitate, we point it like gas, we point upward, precipitate, we press the arrow downward. There are two ways of describing or defining a double displacement reaction. The reactions in which two different atoms or groups of atoms are exchanged. Such reactions are called double displacement reactions. In another way of looking at the same thing is that the reactions in which two ionic compounds in the solution, they react by exchange of their ions to form new compounds. These are called double displacement reactions. In fact, you see all acid-base reactions or neutralization reactions, they are also double displacement reaction. Now let's look at some more double displacement reactions. In the first one you see copper sulfate aqueous solution. It reacts with ammonium hydroxide aqueous solution to form calcium hydroxide, which comes down as bluish white precipitate in ammonium sulfate solution. In the second example you see aluminium chloride in its aqueous solution reacts with ammonium hydroxide in its aqueous solution to form aluminium hydroxide, a white precipitate, and also ammonium chloride, an aqueous solution. Another example is copper sulfate aqueous solution mixes with hydrogen sulfide gas to form a black precipitate of copper sulfide and aqueous solution of sulfuric acid. And the last one is a very common neutralization reaction. You have seen it previously in the acid-base reaction. Sodium hydroxide, a base, reacts with hydrochloric acid to form sodium chloride, the common salt, and water. Now the last one, redox reaction. Actually these are two separate reactions, reduction and oxidation. We call it in short redox reactions. Because usually these two reactions are very closely related, as we will see, and it's very important reaction. And so these usually happen together. We learn only the fundamental steps about redox reaction in this class, but let us look at it. What happens is that we can explain both reduction and oxidation in two ways. Whether it is gaining oxygen, one substance as a result of a reaction is gaining oxygen or losing oxygen. In the same way, whether a substance as a result of reaction is gaining hydrogen or losing hydrogen in terms of, say, oxidation. Oxidation can mean two things. As a result of the reaction, one substance has gained oxygen, that is oxidation. But if A certain substance has lost the hydrogen, that is also oxidation, and vice versa, reduction. It is, of course, gain of hydrogen. But it is also, if as a result of certain reaction, a substance loses oxygen, we call it also reduction. So you see, these two are usually inseparable. It happens separately, of course, but usually these go hand in hand. Let's just learn the basics of it. Say one experiment you have already known, that if we take copper and burn it solid and burn it with oxygen in the air, what happens is that two copper oxides molecules are formed. Here you see, copper has gained oxygen. Copper has gained oxygen. So it is a simple oxidation reaction, no problem with that. But now look at this copper oxide. Say we take copper oxide and mix it with hydrogen gas. What will happen is that copper will be separated again and H2O, that is not liquid but gas, because it is in the white water vapor, so it is gas. Now look at this one. Copper oxide has lost oxygen there and hydrogen has gain oxygen there. So you understand, copper oxide has lost oxygen, so it is a reduction reaction. But hydrogen, it has gained oxygen, so it is an oxidation reaction also. They went hand in hand. So this kind of reaction is called the redox reaction. We learn two more terms before look at some other slides, and also after that we know what are agents of reduction and agents of oxidation. Look at the slides. I am repeating so that you can memorize it very carefully by understanding. Reduction, oxidation reaction, redox reactions. In terms of gain or loss of either oxygen or hydrogen. Oxidation is a process which involves either gain of oxygen or loss of hydrogen. Reduction is completely vice versa. It's a process which involves either gain of hydrogen or loss of oxygen. And here is that example again, an experiment shown in the laboratory apparatus. Copper 2 oxide, which is black. Copper 2 oxide because 2 stands for the valency of that compound. And hydrogen gas. And now copper reddish brown, it is formed, and water vapor with it. This is called the, at the same time copper is being reduced and hydrogen is oxidized. So it's a redox reaction. Two conceptions we must be learning very carefully. while we talk about redox reactions. Oxidizing agent and reducing agent. What are they? Oxidizing agent is a substance that while a redox reaction goes on, it helps either in loss of oxygen, it helps to lose of oxygen, or gain of hydrogen. The substance that in a redox reaction helps either in the loss of oxygen or in the gain of hydrogen is an oxidizing agent. Vice versa. What is a reducing agent? It is that substance that in a redox reactions helps either in the loss of hydrogen or in the gain of oxygen. Be very clear about it. Oxidizing agent and reducing agent. You will see on careful thinking the substance that undergoes reduction. The substance that undergoes reduction is called the oxidizing agent. And the substance that itself undergoes oxidation is called the reducing agent. Be very careful to have it clearly understood. We will go through a few slides also. Let me give you one or two examples here. Let us say we are taking copper oxide. Actually, this is called the copper 2 oxide. I explained in the previous class why it is 2, because valence of this copper oxide is 2. What will happen is that it will separate into copper and H2O. Now, I am not going through the detailed equation, I am just showing how a redox happens in terms of gain of which is the reducing agent and which is the oxidizing agent. You see, what happens here? Copper oxide has lost an oxygen and hydrogen has gained an oxygen. It has lost an oxygen. So it has been reduced. Copper oxide has been reduced. So it must be the oxidizing agent. And hydrogen that has gained an oxygen. That has gained an oxygen. It has been oxidized. So it must have been the reducing agent. If we had, this is in terms of loss of oxygen or gain of oxygen. Let me give you one more example. Look at it carefully, and then I will give you another example. in terms of loss of hydrogen and gain of hydrogen. If you want, you can stop the screen here and see. Let's go to the next page. Now we take hydrogen sulfide gas and chlorine gas. It is gas and also chlorine gas. You see, what will happen is that and sulfur, that is also in the gas. It is also gas, HCl, and this is also gas. That doesn't matter. Point is that we have to keep some heat here. That is also the matter in this reaction. What I want to say is, look at this H2H, hydrogen sulfide. It has lost hydrogen. And chlorine, it has gained hydrogen. Hydrogen sulfide has lost hydrogen. So it has been oxidized, and what has been oxidized must be the reducing agent. And what happened to chlorine? Chlorine gained an hydrogen. It has been reduced. It has undergone reduction. So chlorine must have been the oxidizing agent. Let us go through a few more examples. Oxidizing agent is a substance which undergoes reduction itself and helps the other substance to undergo oxidation. It helps either to lose oxygen or to gain hydrogen. On the other hand, reducing agent is a substance which itself undergoes oxidation but helps the other substance to undergo reduction. It helps to either lose hydrogen or to gain oxygen. We have already seen two examples. In the first one, we explained this redox reaction in terms of gain of oxygen and loss of oxygen. And in the second example, we explained it in terms of gain of hydrogen and gain of loss of hydrogen. Now we give the third example, in which we explain in the same redox reaction in terms of loss of oxygen and loss of hydrogen. Look at it. Here hydrogen sulfide gas is mixed reacting with sulfur dioxide gas. The result being sulfur and water. What happens is, look, hydrogen sulfide, it loses hydrogen, loss of hydrogen. So hydrogen sulfide is undergoing oxidation. It is a reducing agent. And sulfur dioxide, it is losing oxygen, so it undergoes reduction and it is the oxidizing agent. This is the third way of looking at a redox reaction. Another conception, you will not need it much at this stage of your learning, but as well you can be acquainted with it. That is the electronic conception. It's a new conception. Electronic conception of redox reaction. Explaining the redox reaction in terms of loss or gain of electrons. The substance that undergoes a loss of electron in a process. The process which makes a substance lose an electron is called oxidation. And the process in which some substance gains an electron, we call it reduction. Let me give you one or two examples. Suppose we take, it happens in the ionic compounds, ionic consumption, take magnesium and combine it, burn it in the air, oxygen. What happens is that two molecules of magnesium oxide is formed. But in this ionic compound, magnesium oxide, actually what happened is that magnesium is a 2+ ion because it has lost 2 electrons to combine with oxygen. And oxygen, it has gained 2 electrons, so it is now in 2- ion. So what happened according to this conception is that magnesium, it has lost electron and oxygen by the same process has gained electron. Magnesium has lost an electron. So in that sense, that is oxidation. And oxygen has gained electron. That is the reduction. So according to this conception, you see that since magnesium has been oxidized, it is the reducing agent here, and oxygen has been reduced, so it is the oxidizing agent here. Just take one more example. It's a very common example. You know how HCl, hydrochloric. We are taking 2 gases, hydrogen gas, chlorine gas, to form 2 molecules. Hydrogen chloride commonly known as hydrochloric acid. In this, you understand, it's very simple. In the ionic formation, actually hydrogen is in +1 ion and chlorine -1. So what happened? Hydrogen has lost an electron. Chlorine has gained an electron. Hydrogen has lost an electron to form a cation. Chlorine has gained an electron to form an anion. And since it has loss of electron, we call it this process is loss of electron is the process of oxidation. So hydrogen must be the reducing agent. And chlorine, it has formed an anion. This process has gained an electron. So this is the process of reduction. And so chlorine must be the oxidizing agent. The substance that forms a cation is the reducing agent, and the substance that forms an anion is the oxidizing agent. This is another way of looking at reduction reaction. You better to keep it also in your head. Look at one or two extra examples here. Look at it. Here, iron and sulfur reacting in presence of heat energy is given. That is not the point. Iron and sulfur reacting to form iron sulfide, in which iron has formed 2 plus ion cation, and sulfur being non-metal, it formed anion 2 minus anion. So iron has lost electrons. Is being a metal, it has lost electron to form a cation. So iron has undergone oxidation. So iron forming a cation, it is the reducing agent. On the other hand, sulfur, it being a non-metal, it has gained electron to form an anion. So it has undergone reduction, and hence sulfur here is the oxidizing agent. Now look at the next example. Here copper and iodine, they react together to form cupric iodide. Where copper is being a metal, it has formed cation, and iodine being the non-metal, it has formed anion. So copper being a metal, it has lost electrons to form the cation. It undergone the oxidation. So copper is the reducing agent here. Iodine, the non-metal, it gained electrons. It has undergone reduction to form an anion. So iodine is the oxidizing agent here. Please try to understand the difference. You will not need it in this class, but it is better that you learn it at this stage. Now, as a conclusion, we will discuss two very common examples of oxidation in our daily life. One is rancidity and one is corrosion of metals. Rancidity is, you know, when in some food it goes sour in taste. After leaving it exposed in the air, it tastes sour. What happens is the fat or the oil, usually it happens with an oily food or more. If you leave it in the open air, the fat or oil, it gets oxidized and gives out a bad smell. This is called the rancidity. There are methods of preventing this rancidity, like vacuum packing, etc., adding nitrogen instead of air. Let us look at some of the common examples of how we can prevent rancidity and preserve food for a little longer. Please look. The oxidation of oils or fats in a food resulting into a bad smell and a bad taste, sour taste. This is called rancidity. There are several methods to prevent rancidity. We do it by adding different kinds of antioxidants to the food, by vacuum packing, and sometimes we also pack by replacing the air with pure nitrogen. And of course, the most common at home, the process of preventing rancidity is refrigeration of food, keeping it in a cold place. The second part is corrosion of metals. You have known that the metals, particularly the iron, if it is exposed to the water and air, oxygen, it often gets rusted, jung like jung. It happens with the other metals also. What happens is that, what is corrosion? Corrosion is eating up of metals, wearing of metals by the atmospheric gases, not only oxygen. It may be oxygen, it may be carbon dioxide, it may be hydrogen sulfide, H2S. And as a result, that metal is corroded and formed either oxide or carbonate or say sulfide. We call this process of turning a metal in reaction with the atmospheric gases into its metal oxide, carbonate, sulfides, etc. This process we call corrosion. Let's take an example. Say we take argenta, silver, and leave it exposed to hydrogen sulfide gas. Hydrogen sulfide gas. What will happen is that now this argenta silver forms a sulfate, is now silver sulfide, and hydrogen gas is separated from it. You see, this process is called the corrosion of silver. If you leave some silver ornaments, you will see that it gets some dirty specks of it. In the same way, if we take, say, copper, it's solid, leave it, a ring of copper, leave it, or in open air. It takes, say, from here it takes carbon dioxide gas. Let's for an example, it also reacts with O2 gas, and it is also exposed, so it may be reacting with the water. If you have a ring of copper, it is exposed to the water when you are washing your hair. All these help corroding that copper ring, and it produces, it's a new kind of we call it basic copper carbonate. After using one copper ring for long, you will see that it gets corroded into a defined kind of metal. These are some examples, and I will give you one or two more slides. Look at them. This is the most common example from everyday life of metal corrosion. Here you see iron is rusted, how it happens. 4 molecules of iron, when exposed to the open air, and it reacts with 3 molecules of oxygen and say X number of water as moisture present in the air, and all together they react to form a hydrated ferric oxide. You see it has X number of molecules of water of crystallization in it. This is what we call rust. And just to remind you about the importance of knowing what it is, let me define again what is rusting or corrosion. The process of slowly eating up of the metals due to attack of atmospheric gases, not only oxygen. It may be carbon dioxide, it may be hydrogen sulfide, it may be water vapor, etc. Process of slowly eating up of metals due to attack of atmospheric gases such as oxygen, carbon dioxide, hydrogen sulfide, water vapor, etc. on the surface of the metals, so as to convert the metal into oxide, carbonate or sulfide, etc., is known as corrosion. The common way of preventing the rusting of iron you have seen at home. We do it by painting the grills, the railings, the exposed part of the iron. We grease or oil the exposed part of the machinery. And we sometimes also galvanize, electroplate some part of the machines or apparatus to prevent this rusting of iron. So students, this is the how your first chapter, a very important chapter, chemical reactions and equations. I hope you have enjoyed it, you have learned it, and I have perhaps inspired you to look on yourself through internet and different kinds of videos on YouTube and learn a little more. Do the exercises I have given you very seriously, and buy, once more I am telling you, buy a periodic table chart and just keep it before your eyes. We will come back very soon with the next chapter, another very important chapters, acids, bases and salts. Till then, stay home, stay safe, stay strong, stay studious. Goodbye. Thank you.